there, we're going to do this last couple of worksheet tutorial. It's over wavelength, frequency, and energy. At the top, we have the formulas that we're going to need. Energy is equal to Planck's constant times frequency. Speed of light is wavelength times frequency. Speed of light is 3 times 10 to the 8th meters per second, or in case we need it, 3 times 10 to the 10th centimeters per second. And then we have Planck's constant is 6.626. It's not a negative. It is actually 6.626 times 10 to the minus 34th joules per hertz. So let's get started. Remember that we're always going to try to box the given and circle the unknown. A certain violet light has a wavelength of 4.13 times 10 to the minus 7th meters. That's my given. What is the frequency of this light? That's my unknown. So if I have wavelength and frequency, I go up here to these two formulas and decide which one I'm going to use. Well, this one's the only one that has wavelength and frequency. So I'm going to use the speed of light frequency. Okay, so I have wavelength equals, what was it, 4.13 times 10 to the minus 7th, and frequency is what I'm looking for, and speed of light is 3 times 10 to the 8th meters per second. So I'm going to plug in my numbers in the formula. Speed of light is 3.0 times 10 to the 8th. Set that equal to, we'll do wavelength, 4.13 times 10 to the minus 7th times frequency. So in order to get frequency by itself, I'm going to divide both sides by 4.13 times 10 to the minus 7th. 4.13 times 10 to the minus 7th. And then we'll see what that is. So I'll get my calculator out here. 3 times, not 30, 3.0 times 10 to the 8th divided by 4.13 times 10 to the minus 7th. So, 7.26. Well, let's see, there's 3 sig figs here, so I need 3 sig figs here. 1, 2, 3. That 3 that's next to the 6 doesn't round the 6 up. So it's going to be 7.26. My exponent is 14. 7.26 times 10 to the 14th. Frequency is hertz, or S-1, your choice. Okay, what is the energy of this light? Okay, anytime we see the word energy, you have to use this formula, no matter what. Okay, so energy is equal to Planck's constant times frequency. We got frequency, it was right over here. So energy is what I'm looking for. Planck's constant, 6.626 times 10 to the minus 34th, and frequency was 7.26 times 10 to the 14th hertz. Okay, plug my numbers in. There's my formula right there too. Energy is going to equal 6.626 times 10 to the minus 34th times frequency. Okay, we'll see what that comes out to be. Let's see, 6.626 times 10 to the minus 34th times 7.26 times 10 to the 14th. Bam! 4.81 times 10 to the minus 19th. My formula. There it is. And it's joules. Sorry, I didn't put a unit. There's my answer. Okay, number 2. What is the energy? There we go. So I know what I'm using. What is the energy of a quantum of light that has a frequency of 4.31 times 10 to the 14th hertz? Well, I'm looking for energy. Planck's constant, 6.626 times 10 to the minus 34th. And then there's my frequency, 4.31 times 10 to the 14th. Plug my numbers in. Energy is equal to 6.626 times 10 to the 14th. Sorry, looking in the wrong place. 10 to the minus 34th times 4.31 times 10 to the 14th hertz. So let's see what that comes out to be. Cover that up. 6.626 times 10 to the minus 34th times 4.31 times 10 to the 14th gives me 2.86. See, I need 3 sig figs. 1, 2, 3. The 5 that's next to that other 5, it's going to round it up. So it'll be 2.86 times 10 to the minus 19th power. Since it's energy, the unit is joules. What's the wavelength of this light? Okay, well, we're going to use the formula here. Oh, you can't see that. Right here. Okay. Speed of light is equal to wavelength times frequency. We have the frequency. It's right here. Okay, we're going to use that frequency. Speed of light, 3.0 times 10 to the 8th. And then wavelength is my unknown, and frequency is 4.31 times 10 to the 14th. Plug into my formula. 3.0 times 10 to the 8th equals wavelength times 4.31 times 10 to the 14th. Okay, in order to get wavelength by itself, I have to divide both sides by 4.31 times 10 to the 14th. Okay, and wavelength is, there we go, 3.0 times 10 to the 8th divided by 4.31 times 10 to the 14th. 6.96, sorry about that, 6.96 times 10 to the minus 7. And what we wavelength is meters. There we go. There you go. Alright, there's the first couple, and I'm going to do one over here. Calculate the energy of a photon of red light with a wavelength of 6.45 times 10 to the minus 5th centimeters. That's why I did that one, because you guys needed one with centimeters. So in order to use our formula, sorry about that, in order to use our formula, we're going to use energy is equal to Planck's constant times frequency. I need this, okay, I need to use this formula, but I can't because I have wavelength. So what I need to do is I need to plug this into the formula for the speed of light and calculate frequency. Okay, I can do that. You can do that. Okay, speed of light, sorry about that. Speed of light, I'm trying to get it so you can see it. There we go. Speed of light, 3.0 times 10 to the 8th. Looks like 30. Oh, we want to use times 10 to the 10th because it's centimeters. We want to make sure and do times 10 to the 10th. So 3.0 times 10 to the 10th centimeters per second. Remember on that first page we had some conversions here? There's the speed of light in meters per second. There's the speed of light in centimeters per second. And since we have centimeters for the wavelength, we need to use centimeters per second in this formula to make everything come out okay. Alright, so we also have wavelength is 6.45 times 10 to the minus 5th centimeters, and I want a frequency. Plug my numbers into this formula. 3.0 times 10 to the 10th equals wavelength 6.45 times 10 to the minus 5th times frequency. And that should actually be frequency. Sorry about that. Alright, so divide both sides by 6.45 times 10 to the minus 5th. And I will have solved for frequency, and then I can put it in this formula. So let's see what that comes out to be, the frequency. 3.0 times 10 to the 10th divided by 6.45 times 10 to the negative 5th power. Okay, so my frequency is 4.65 times 10 to the 14th. Okay, that's my frequency. I'm going to plug this frequency into the formula for energy. So energy, I'm going to, oh, there's the frequency. Frequency is right there, because it's asking for frequency here. So there's the frequency, 4.65 times 10 to the 14th hertz. Okay, and I'm going to use this number in my formula for energy. Energy is equal to Planck's constant, 34th, golly, sorry about that, kids, minus 34th times the frequency, 4.65 times 10 to the 14th. Okay, I'm going to multiply those two guys together, and that's going to give me the energy of this photon. Times 10 to the 14th, there we go, bam, 3.08 times 10 to the minus 19th. Energy is equal to 3.08 times 10 to the minus 19th. And the unit for energy, joules. So, there you go. Kind of messy, kind of all over the place, but you can solve for it. Remember that you can use these, you know. If you've got wavelength and you need frequency for this formula, calculate the frequency. You can do that. Okay? All right, well, have fun. Do the rest of them for me.